Hey everybody, nice to be here. Yeah, it was a little weird to find out that I am actually clickbait in the tables in the Remo tool. So that was weird, slightly awkward. Thanks for having me. Thanks for hosting me. So many GDGs involved in this. So right before the talk, I thought, oh, I should customize these slides because it's this generic template that we use underneath the slides that we have for this talk. And it just says GDG location. And ideally, I would go in and say GDG Istanbul, GDG Boston, GDG whatever, right? And then I realized, no, there's so many GDGs. Why don't I just leave it as GDG location? Because I think that's actually more correct than any one in particular. It's like GDG Western Hemisphere. And yet I talked to somebody at one of the tables from India. So it's not even Western Hemisphere. It's basically GDG universe. So
I have a GDG location shared here.
Yep. Point in fact, yes. Nice to be here. Nice to be everywhere. Nice that everybody could actually join us for this talk from wherever you are calling in for. It's unfortunate that the world situation has taken us all home and away from work and away from the ability to actually travel and see each other in person. On the other hand, it's kind of amazing that all the communities were able to turn around so quickly and offer these online events that don't offer the same experience. Like, yes, I still do miss the in-person events, the ability to actually talk to people in person and, leave my house occasionally. But it's really nice that people have the ability to call in from wherever they are at all hours of the day and night and participate in these events. So it's nice that we could actually pivot and still do some version of the things that we were doing before that help engage us as developers and help us learn how to do better stuff with all this amazing software. So I am, despite the fact that he said I don't need an introduction, in case you do not have the context, I work in the developer relations team. I've been on Android on the engineering team since 2010. I was on the UI toolkit team for most of that time, doing animations and graphics and leading the team and all that kind of stuff. And then for the last year and a half, I've been in the developer relations team, sort of doing stuff like this. Let's absorb a bunch of information about what's going on in Android development and then try to help communicate that externally and then talk to the communities and bring that information internally. That's sort of the job and sort of my passion as well. I really like doing things like this. So having said that, why don't we actually do this thing? So the question is, in what's new in Android, what is new? So one of those things is Android 11, still not finally released, but the beta 2 came out a week or two ago. That is, it's a new kind of milestone release that we have in Android 11 that we haven't had before called platform stability. And platform stability is where we say, okay, APIs locked, behavior changes done. So if you have not tested your app yet, this is a really good time to do so because you can know that we are not going to change any behavior or APIs up through the final release. So you can actually see what your application behaves like on Android 11 emulators and devices and make sure that it behaves the way you think it ought to, or else you'll have a chance to fix it before the final release is out there. So I will talk mostly about Android 11, a bunch of the features and capabilities that we have in this release. I will also talk briefly about some of the tools that we offer and the tools capabilities and some of the unbundled libraries, which is more and more a focus of more of the engineering teams in Android as we put capability not just in the platform, but also in these unbundled libraries that you can then use across releases. So let me start with my favorite area, which is the user interface area. There were some really interesting changes there. The first of which I'll talk about is window inset. So traditionally, we would give you information about the geometry changes that happen on the device, but we didn't actually give you much information, right? It was really opaque what was going on. There are several windows involved there, but all we said was, hey, here's the geometry reactions, the geometry information that you need to react to. Well, wouldn't it be nice if you actually knew, yeah, but are you talking about the status bar? Did something happen with the keyboard, the navigation? Like what exactly is going on there? So now what we've done with the window insets is we basically deprecated most of the old API because that was the useless API that really didn't give you enough information. And now we've introduced new parallel APIs that actually give you information about, okay, for this geometry, what is the window and the situation that we're talking about here. So we'll take a look at a little bit of sample code. So you have this listener that gets the window insets information. And from there, you can do things like query, hey, is the keyboard visible? Seems silly, but you couldn't ask before. And now you can. You can say, okay, for this specific window, what is going on with it? And more interestingly, what are the window insets for that specific item on the screen. So one of the questions is, so we've had window insets, APIs, and capabilities for years and years. What was the impetus to change it now, especially go through a massive deprecation thing? Besides the fact that we should, because we want to improve these things, why now? Well, a big reason for it is one of my favorite features, which is IME animations, the ability to actually synchronize the motion of the keyboard with the motion of the content in your application. You couldn't do that before, and you hated it, and so did we. And we have been working for quite a few releases. I know engineers that have been working on solving this problem for at least the last 2 to 3 releases. It almost made it in Android 10, but now it finally made it the ability to actually find out what's going on in the keyboard so that you can react accordingly, even frame by frame if you want to. So there's 2 approaches to this. One is that you can listen for changes that are happening to the keyboard and then react to those, as I said, frame by frame to see what you want to do with your content, sort of scroll it up out of the way, reduce the size, whatever you need to do, right? Or you can actually drive the keyboard animation directly. So let's see examples of both of those. So there's a sample for IME animations that's posted. I'll give you a URL to it later. On the left-hand side, it does 2 different approaches. On the left-hand side is the traditional keyboard animation where it just pops into place. You know, it has this nice smooth animation, but until Android 11, you couldn't animate with it. Instead, you just get one event that says, oh, by the way, insets have changed, you better react to it. And then your content would snap. Well, now you can actually react with it. As it animates in, you can animate your content because you're going to get a frame by frame piece of information that tells you what is going on so you can react accordingly. On the right is the more manual approach where you can actually drive the animation of the keyboard. So we actually see the user moving, scrolling that content up, and as they do, we can actually scroll the keyboard up and down into place to suit. So we'll see really quickly how this works in code, or at least some of the APIs. So the example that we saw on the left where the keyboard automatically just animates in, you can have an animation callback that gets the lifecycle events of that animation. You can find out on a frame-by-frame basis what is going on and then react to that information. For the example that we saw on the right earlier, as the user is scrolling along, we can actually drive the animation. There's 2 approaches we could take here. We could just do a set and forget approach, which is how you run most animations on the platform, where we would set up an animation with parameters like this and say, okay, I want it to last this long. It's going to have this kind of motion curve. And then we would animate appropriately. In this case, since we're actually interacting with the user, as the user scrolls the content, what we really want to do is frame by frame, move the keyboard up and down appropriately according to how much the content in the application is moved. So here we set up an animation on the window type of the IME or keyboard. We say infinite duration because really it's going to be based on when did the user stop that motion. Linear interpolator because we don't want any kind of motion curve. We just want to react to it frame by frame directly. Cancellation signal allows us to cancel it along the way or react to that cancellation if we need to. And then we can find out lifecycle events of when that animation is canceled if that's what we need to do. All right, so if you want to find out more about that, check out the sample. The screenshots that are showed before are at that URL, so you can go grab the code and see how to do this in your application. Another big area of UI changes in Android 11 was conversations. There's a bunch of people directly around people, right? It is clear that most of us spend most of our lives now on these little tiny screens, and what are we doing? A lot of it is interacting with the people in our lives, whether it is our colleagues from work that we used to sit next to in the office when we used to have offices, or it is family or friends or whatever. We are constantly interacting with these people in messaging, in email, however that is, and there's the need to get back to those conversations, to sort of have these ongoing conversations in the most convenient way possible. If someone messages me again, and then I have to quit this application, go back to home, and launch this other thing, and then click, 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 and get down this sort of deep trough of UI just to get back to a conversation, it's kind of tedious. And so we wanted to make that as seamless as possible. One of those ways is through conversations, where now when there's an ongoing conversation in one of these applications with someone in your life, that is going to show up in a different dedicated place in the notification panel. So in this conversations area, and you can see that in the screenshot here, you have these 3 notifications that are specific to people that you're in the middle of conversations with. So not only do they show up in this sort of high priority area, and you could tap on any of those and go back to that conversation, but you can also affect information about those and really tune that experience. So So if you long press on one of those, you can say, well, for this kind of notification from this category person, I want to be interrupted in the following way, or I want to change the priority of this. Turns out the school that I'm conversing with is really important. I need to find out what is going on with my family, so let's make that a high priority conversation. And then it moves that to the top of that list, and it will remember that choice. The way that you interact with this API is a lot of this API already existed. The person API, I think, came in Android 9 or 10. You build this person capability with the information about that person that you're having a conversation with. You create a shortcut. It needs to be a long-lived shortcut. So it's one of the nuances that is new there. You push that shortcut, and you also need to use messaging style. This is a requirement of this approach. And then we build and push the shortcut with the ID that we created above. So once you've got all that nailed, it's pretty easy to then tune into one of the other people-oriented UI changes in Android 11, which is bubbles. So again, there's a sample that I'll link to later that you can check out for using the new bubble stuff. But you can see the screenshots here from that sample. You've got a bubble up in the upper left, and then if you tap on that bubble, it pops up this dedicated UI on top of everything else, right? This is the key. Bubbles float on top of the entire UI. Applications used to use status alert window for this. We do not want that to be the case. That's a really heavy hammer for solving this problem. Instead, use bubbles for this, right? It's going to ride, the bubble's going to ride over the UI, and then it's going to pop up this little mini activity that rides over the UI and allows the user, again, to get directly back into that conversation. Oh, I should point out, too, that that UI, the user has to opt in. This is not going to, decorate all of our screens with bubbles all the time from random applications. When you pop a bubble up or you want to pop a bubble up in front of the user has to opt into that experience in order for that to happen on their device. All right, so the notifications, one of the nice things about bubbles and a lot of the stuff going on in the people and conversations area is a lot of this technology really works together, right? So you have the notification that you created before for the conversation stuff that we were talking about. And now a lot of that information is basically automatically usable by bubbles. So we almost offered this, just like IME animations, we almost offered it in Android 10, but it wasn't quite ready. We really needed to hammer on the use cases a bit more before we bake the API and the capabilities of it. So we offered it as a developer option, encouraged people to use it, but users weren't really seeing this. It was really for developers of applications. But Android 11 is a full feature. So please do use that thing, and please do not use System Alert Window. System Alert Window is still there. There are some other use cases that maybe people are using it for, but one of the really common ones was for this type of capability. So you should really change your apps to use bubbles instead. So you use the notification stuff that I was talking about before, but you also add a little bit more metadata to give it information about the bubble you're creating, and you create a little mini activity, and that's the little activity that rides on top when someone taps on one of those bubbles. So you do that by, in the manifest, you have this other activity you're creating. It needs to be a resizable activity. You'll notice that little mini activity, it was a mini activity. It was on top of the other UI, but you could see stuff behind it. So the system needs the ability to actually resize that window. So it needs to be a resizable activity. And then on the code side, you need to actually create that activity, create the intent, create the metadata for the bubble associated with that, create the notification, which you were probably already doing before for the conversation stuff or for other notifications that you're propagating anyway, except now you just need to add that bubble metadata to it to make sure that it actually expands into or appears as a bubble. So information on all this stuff, you can check out the sample that that we were looking at before, user interface samples / people. So check out the Android samples for more information on how to do the actual code behind that. And then there were 2 ADB podcasts that we did with the engineering teams on that. Episode 140, we talked to engineers on the Bubbles team about how all that stuff works. And then the next episode after that, we talked to the people on the conversations team. All right, I would like to talk about privacy. I'm not sure I'm allowed to. So every release includes changes, some behavior changes too, around the area of privacy. And that is only accelerating recently as everybody is really getting more and more tuned into how important it is to preserve user data and for users to understand what is happening with their data. And so we are putting more capabilities in the platform to do just that. But one of the things that is good for developers is to find out what is actually going on in the application. So imagine on the left, you've got this code base that's really huge. Either you wrote a lot of code over many years, and now it's just spread out all over the place, and it's sort of hard for you to figure out what's going on where. Or more realistically, maybe you're on a large engineering team, or you're inheriting code from another team, and basically there's a bunch of stuff going on in the source base, and maybe it's a mystery what they're asking for when, or maybe you're pulling in libraries and they're asking for permissions. And what happens when your application that you thought you had a handle on is asking for a permission from the user for sensitive data that you don't think the application needs? It can be a little tricky to track that down in a large source base. So we introduced data access auditing to make that a little bit easier. And with data access auditing, you can now find out whenever the system is asking the user for that permission, you can find out from call stack where that request is coming from and better track down either the context, which may be perfectly reasonable and okay, or track down a fix for that if you really shouldn't be asking for that anymore and you want to lock that down. So here's what it looks like. You create this callback and then set that on the ops manager to find out. And there's a couple of ways you can find out. You can get the call stack. When that call is actually made, you can find out the code that it came from. You can also tag your code and get more specific information about what's going on and when. One-time permissions are sort of an expansion of an idea that we had in the previous release, where previously we said, oh, do you want to grant this permission when the application is in the foreground, or do you also want it to happen in the background? And it turns out a lot of users opted into the no, only in the foreground, right? Once they realized what was going on, like, why would I want this application to have that permission all of the time, right? Well, if they want that, maybe they also want the capability to just say, give the app the permission right now because I understand why they need this. But after that, we're done with this relationship, right? So we have this idea of one-time permissions where the application can say, would you like to do this? And the user will say, yep, I'll let you do that now. And then when the application goes into the background, a little bit after that, then the permission is revoked. One important thing about this is this should not require work on the part of developers if you're already using best practices to implement permissions, which is a couple of releases ago, we came up with the capability for users in the settings to actually disable permissions, right? This is all about transparency of the user, understanding what applications are doing, and giving them power over those permissions. So even if they granted a permission sometime in the past, they can go in later into the settings dialog and say, wait, that application wants that permission? Why do they need that thing? I'm not comfortable with that information being shared, and they can disable that. Now, the best practice is for your application to handle that, and then when you need that permission in the future, you need to re-authenticate. You need to ask the user again, hey, I need to use this permission for the following purpose. And then you need to get the permission again, right? So hopefully you've already done that, because that is the way applications need to run on Android. And if you have, that should already handle this case. So if the user says, yep, you can have this permission, but revoke it when you're not in the foreground anymore, then that code path should already be in there, and hopefully you won't have any work to do for this. Background location. So this has been an ongoing thing in the last few releases, getting more restrictive on who has access to location and when. And there were various ways to get information on location on the user. And so we're locking down all of those. One is getting the location in the background. Again, we want to make it more obvious and transparent to the user, and not just sort of this auto grant thing that maybe they didn't notice. So it used to be possible to request both foreground, but to request location in both foreground and background situations. Now you need to request them separately. You need to say, I need permission while I'm in the foreground, and I'd also like it in the background. That needs to be A, a separate request, and B, it will take the user to the settings dialog. And this is another thing about transparency of these permissions, to make sure that the user understands what's going on. So they're going to get to that setting and they're going to realize, here's what's going on with my location information on this device, and they can make the right choice for them. In the previous release, we already had the requirement that if you wanted location information in a foreground service, you needed to add that information to the manifest. Now we are adding the same restriction, the same constraint for camera and microphone. So if you actually want that information in foreground service, you need to add information to the manifest, and you can add that as this set of flags that you OR together. All right, there are other privacy changes, a ton of them. I'll mention some quickly. You can no longer get access as an application to finding out all of the things that are installed on a device. Instead, you need to specify in your manifest what applications, what packages you would like to know about. So that, again, that is clearer to the system and to the user what is going on. Scope storage, there were more changes made to make sure that we are protecting the files and all of that private data of the user. There were also some improvements for usability to make it easier for developers to migrate to scope storage, including things like access to raw path names and to do batched editing. So no longer doing one by one, but actually doing access to several files at a time. Also, auto reset permissions kind of linked to the one-time permissions from before. Like, why? So if the user installs an application and runs it once, maybe when they install it, and the application asks for a bunch of permissions, and the user says, yeah, click, 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 whatever, and then they never run that application again, why should that application still have access to, let's say, location in the background? Why should it have the capability to do things and use users' data just because the user granted that 2 years ago, but they never run the application since then? So after some amount of time, those permissions get revoked, and then the application needs to request them again. Again, if you're using best practices, should not affect you or your application, but you should know that this thing is happening. All right, there was a bunch of stuff that we did in the release that was specifically about making it easier to develop Android applications in general. This is sort of an ongoing effort. It always has been, but I'd say the last few years, a lot of the effort on the team is trying to identify the problem points and then fix those one by one. One of those was the ability to do Wi-Fi debugging, because I don't know about you, but I never have enough USB ports. That is a picture of the laptop that I'm actually presenting from right now, except now it looks worse. There are more cables and there's an additional dongle. I actually have a daisy chain of 2 USB dongles because I also ran out of USB ports on the dongle. So I got 4 on the machine, I've got 3 or 4 on that dongle and 3 or 4 on the other one, and I still run out of ports, right? So wouldn't it be nice if you could actually connect over Wi-Fi? So you can do that now. It's a bit of a manual process. You need to enable it through a UI on the device and then use a command line option to actually connect and pair with the device over Wi-Fi. However, it is enabled through alpha version of Android Studio, Canary version, and I'll talk about that later. Another thing that we've done for developers is nullability annotations. So we annotate platform APIs. So the platform APIs are in the Java programming language, but if you're a Kotlin developer, it's great to be able to take advantage of Kotlin language features around nullability to make sure that your code is obeying the contract of the code underneath it. So we're adding annotations to the Java programming language APIs that we have that allow you to do that. There's a couple in particular. There's the recently and the non-recently version. So recently is annotations that we add that are new, either recently nullable or recently non-null, that basically says this parameter, this method, whatever, can be null or cannot be null. And then if your code is calling it in a way that is disobeying that contract, then that will flag as a build warning. You do not have to fix it. We suggest that you do, but at least we won't break your build. But if we had a recently annotation before, then in the most recent release in Android 11, we may have upgraded that to be just flat out nullable or non-null, which means that if your code is calling it and is not obeying the contract, your build will break and you will fix it because you will not be able to build otherwise. So this is all about making the platform more robust, your application more robust, because it's great to be able to catch these errors at build time. You are calling it wrong, so you should fix it. And it's really better to find that out at build time rather than runtime on the user's device. Crash reasons reporting. This is also about finding out things from the real world, right? So it's really hard to find out what is going on in your users' devices. Chances are their devices, especially across the vast ecosystem that Android is, are nothing like your testing setup. No matter how many devices and emulators you use, no matter what versions you're running, no matter what other applications you have installed, you're not going to be able to replicate all the things that your users have out there in the real world. So finding out what actually happened on the user's device is really kind of key. So we've added an API around that to allow you to do that. You can find out when your application has crashed in the past, why did it crash, and then you can upload that report so you can take a look at that and get more information from the real world. So you do that by calling this get historical process exit reasons, and then you can iterate through that and find out what was going on. Was it, did you run out of memory? Was it just a flat out native crash due to null pointer, whatever? Was it an ANR? So you can use this API directly. We'd encourage you to if you would like to. Maybe use a crash reporting service. And I talked to some people on a crash reporting service, and they said some of this information is really hard to get directly. And by the platform providing this information, like saying it crashed because of an ANR, that's really helpful to crash reporting services. So even if you're using a crash reporting service, you may in the long run benefit from this because we're able to give more direct, specific information to those services as well about here's what happened when the application went down. GWP ASAN is also about getting real world information. So in Android 10, we had something called HWASAN, and this was about a build and test environment capability that gave you more information about memory problems that you're having. So instead of using, this is for native developers, this is native code, this is not sort of standard Java and Kotlin side Android SDK. But if you're doing native development, when you call, you're calling malloc, you're allocating memory, you're deallocating memory, you're on your own. But with HWASAN, we inject an intermediate layer there so that when you're calling an allocator or deallocator, you're actually calling through our code along the way, and we're tracing information on the way down and on the way back up to make sure that when you free that later, when you use that memory later, you're using it or freeing it correctly. And if you're not, then we're going to know about it, we're going to crash, and we're going to give you that information, which is awesome. But it's also only at build and test time, right? Because we're basically putting this intermediate layer over all allocations, which is overhead, and it's also a ton of memory relative to what your application is using otherwise. So this was never intended for the real world, but we came out with GWP ASAN, which is. So this is a sampling approach to that. So instead of overlaying all memory accesses, all memory allocations and deallocations, we're just doing it on a sample basis, knowing that in the wide world, if we're doing a little bit here and a little bit there, in the wide world, we're doing a lot of it in a lot of places. So you're going to get the information that you need. In this case, since we're only doing it on a sample basis, I think the overhead of the library, it's only like 60K, right? Like quite small for doing what it's doing. And it is sort of an automatic service. You basically opt into it. So in your manifest, you say GWP ASAN mode equals always. You can also opt in just for specific modules or sub-activities in your application. And then when one of these problems is encountered, then we'll automatically crash and output this log, and that will be uploaded into your Play dashboard, so you can check out those logs. ADB incremental is about faster installs. So let's say you have a game and it's 2 gigs, right? Massive thing, and every time you fix one line of code, you need to wait for the build of that one line of code, hopefully not that big, but then the install of this 2 gigs worth of stuff down onto the device. We have made it possible to now only install incrementally the stuff that changed, and you get installs that are up to 10 times faster. This is probably not worth it for many applications, but again, if you're a really large game, you have tons and tons of assets that have to get installed every time. This can help you avoid that problem. It's a little bit manual again, like the Wi-Fi debugging. You need to, on the command line, say install -- incremental, and also use a slightly different signature mechanism. But worth it if you've got this big game and you're waiting a lot. Or maybe it's just a great time to drink a lot of coffee over and over again. All right, so behavior changes are difficult. We know that, like some of the privacy stuff that I talked about earlier, and we will continue to make those changes as we realize this is an issue and needs to be addressed. But moving forward, this is how you incrementally move the platform forward. However, then developers need to deal with these behavior changes. There are a couple of things that we've done to hopefully mitigate some of that for developers this time around. Most of the behavior changes that I talked about and on the platform in general are limited to target SDK-R. So if you are targeting this release, you need to handle those behavior changes and do the right thing. But if you are not yet targeting this release, this basically gives you a little bit more time before you need to spin up to that. Also, it's easier to test these behavior changes on your application. So you can already test it through the command line. This is an existing ADB shell command. But now there's also a new UI that we have in developer options that you can use that does the same thing. It looks a little bit like this. So for each one of the behavior changes that we have, they show up here in the dialog, and then you can just use the toggle switch to turn it off and on and see how that affects your application. Or you can still use the command line option like I said here. So you could use the command line option to disable that first one there, and you can see, oh, look at that animation. Isn't that nice? You can see it automatically disabled in the UI. All right, on the graphics media side, NDK image decoders, this is interesting. So all of the decoder logic that we have, all of the code that we have that is reading in JPEGs and PNGs and GIFs, GIFs, all of that is in native code. We use the Skia library for doing our rendering, and it also happens to do all the image decoding stuff. However, it wasn't accessible from native code, right? So even all that stuff, even though all that stuff is living in C and C++ code, in order to use the decoders, you had to call it through Java language-based APIs, right? So if you're a game developer or you're writing other NDK code and you want to use one of our decoders, then you had one of a couple of approaches. You could either upcall through JNI and then downcall into our code, or you might just give up at that point and then you bundle another library, bulking up the size of your APK, essentially with functionality that we already offer on all of these devices, but you just didn't want to bother with having to use it in the way that we required it. So now all that stuff is accessible through NDK APIs, saving you the burden of either that upcall or bulking up your APK along the way. Works a little bit like this. You create a decoder from the asset that you have. You set the format that you need to decode into, and then you run the decode. If you're doing 3D graphics, you probably get a teapot, because I'm pretty sure that's all they render in 3D graphics. Animated HEIF files is a lot like what we already do for animated GIF files. You can, if a HEIF file includes several different images, then it will load in as an animated image drawable, which is the same as animated GIF files. But the advantage of animated HEIF files is they are significantly smaller in general. So you do it like this. You create a file and creates image decoder from that file. And then somewhere that is not on the main thread, because you should absolutely never be doing image decoding stuff on the main thread, then you decode the drawable. And if it comes in as an animated image drawable, it means that that HEIF file did have more than one image embedded inside of it. And now it's an animated image drawable, and you can go ahead and start the animation. If you are doing audio developments and you're a native developer using NDK, there's a chance you're using OpenSLES. That is essentially, I'm not sure it's officially, but it is essentially deprecated. There is a better way to do this stuff. There's an open source library that we offer called Oboe. It is, again, for native developers. It's a C++ library. It does high performance audio, low latency audio, which is really what you're after if you're doing audio development. It works across releases all the way back to API 16. As I said, it's open source. You can get it at github/google/oboe. And we talked to a couple of the engineers that worked on this, Don and Phil, in episode 135 of ADB. So if you want to know how it works and how to use it, go check out that podcast. So since the dawn of time, or at least since I have been working on Android, devices essentially all ran at about 60 frames a second, right? So 60 times a second, or about 16.67 milliseconds, there'd be a frame update, right? That's the clock cycle that all these devices use. But now there are devices that can run up to 90 hertz or even 120 hertz. So you've got this variable refresh rate, which means we're updating the screen more often, the user sees more updates more often, and everything's smoother and better. You can take advantage of that if you have your own rendering loop. Again, this is for probably native developers in general, or just applications that are really doing their own rendering through surface views or whatever. It's not for typical Android SDK developers, but this stuff is crucial to them. So one of the interesting things about this is if you've got your own rendering loop and you're doing so much work that you cannot hit that traditionally 60 hertz boundary, like I can't do all of this work in 16.67 milliseconds, like you're doing some timing internally and you realize you're falling off a cliff, you're not able to do it that fast, then you can drop off and at least deliver a consistent frame rate by just dropping down to the next frame rate level. Well, the next frame rate level down is 30. So automatically dropped from all the way from 60 to 30 just because you couldn't quite make 60. Well, one of the side benefits of having a variable refresh rate is you don't have to drop all the way in half, right? There's more back off rates that are available to you. So the way that you can take advantage of this, again, if you're doing this kind of own rendering loop development here, is by calling one of the APIs like surface.setFrameRate. This is basically a request to the system. It is not telling the system the frame rate to run at it, but it is saying, hey, I would love it if you could run at the following frame rate. Now, the system is responsible not just for rendering and updating your application, but also all of the other windows on the screen, like the status bar, navigation bar, maybe you're in a multi-window environment, whatever it is, there are other players that may be at work. And so you submit your request, and then the system may be getting requests from other windows, and it will figure out the best frame rate to run at overall. The thermal API was a capability that was already available for SDK developers. So if you, as a native developer, wanted to use this, then again, you'd have to upcall in order to use it. Now this is available also at the NDK level. And your application, again, probably games or really high performance applications, can react to thermal issues and do the right thing. So basically, if a device is overheating, it's going to start shutting things down. It's going to start running things on small cores. It's going to affect your application. You have the choice to get in there and be part of what that effect is, whether you're going to start using lower res assets, whether you're going to run at a lower frame rate, whatever it is, you can be participating in that conversation instead of just reacting to it after the fact. So here's the way it works. You can have this listener that you set up that then reacts to each of these cases for all of these things. So that there may be status shutdown, which means, yeah, it's really too late. Things are going down. We're just letting you know. Or status emergency, meaning we are going to be shutting things down very soon. Maybe this is a really good time to save state. Or maybe there's status critical OS, and the platform is at the state where things are going to get bad soon, and it's looking for ways out of it. This is a time when your application could back things off, run slower, requiring fewer system resources, basically try to help the system get into a state where it's happy so that it doesn't have to start shutting things down. And then you set the listener, you register the listener here, and then you can unregister the listener later when you're done with it. There's a few other things that are worth mentioning. Neural Network API version 1.3, new capabilities like new condition stuff, like the ability to actually have these branch loops. I kind of would hope any software environment would have that, and now NN API does. Also, hard swish op is really important because not only does it provide higher detection, higher inference capabilities with better performance, but also I really like the name of it. Hard swish op, I think, is a really cool name for a function. There's also new capabilities around memory, makes it less necessary to copy memory around, really expensive operation. We can have these shared memory schemes between GPU and TPU and CPU. 5G, the carriers and devices are coming online with this super high bandwidth, low latency capability. So what could you do from your application? Could you stream higher resolution content? Could you have better connectivity with all the other users in your multiplayer game? And then we have some APIs that you can query and react to get more information about that. So here you can say, am I on one of these, am I on an unmetered network to make sure I'm not going to cost the user money by using this? And am I on one of these really fast networks, and then make the right decision for your application to stream at higher quality levels or whatever. We have the ability to have flexible authentication strength for biometrics, where now not only do we have different ways of getting biometrics, whether it's the visual biometrics or pins or fingerprint or whatever, but you can also say, oh, I want this one to be strong, and then if I am allowed to authenticate, if the user is already authenticated, can I get them to authenticate on this strength level? And then you can follow this one code path. Otherwise, the user needs to authenticate first, and you do the right thing. Autofill in keyboard. So there's this interesting UI dynamic on devices where we've got this keyboard down at the bottom, and I'll take the Google keyboard as an example. There's suggestions on, well, you type this, and it says, oh, you didn't mean the word Chet because Chet isn't a real word, and so it's constantly trying to correct my name for me, which is really kind. But also, then you have maybe a form that you're filling out on some sort of page, and you click in that edit text, and then it's got another UI with other suggestions like autofill suggestions for credit card numbers, for addresses, whatever it is. So you've got basically two areas on the screen dedicated to suggestions about how to fill in this information. So what we've done is we've combined these, so now you can actually share that information, or more specifically, you can share the UI for that information. So you can actually populate autofill suggestions in the keyboard directly so that we don't have all the stuff going on all over the screen. It's essentially duplicating that kind of UI. There are two sides to this. There's the keyboards itself. If you're writing a keyboard app, you should tune into this to find out how to get that information so that you can then present it to the user. And then the other side are the password apps, the actual autofill implementations that have that information and then need to know how to pass it down to the keyboard. Again, it is secure. We're not talking about passing the content itself, that credit card number. We're talking about passing a data structure that wraps the UI representing that down to the keyboard. So here's some visual examples. So you click on that field and maybe it wants to fill it in with an email name in the keyboard or a credit card or US address. So on the keyboard side, at the point where it would like to fill something in, you get this on request or on create inline suggestion request, and you fill in some information about where you can put this thing, and then that gets passed up in the system, and then later you get this response back, and that gives you the information you need to then present that information in the keyboard. On the password side, when one of these situations occurs, you're going to get a callback into on fill request. You're going to fill out a data set just like you normally do with that information, and then you're going to fill out a fill response with that data set that gives it the information from the password from that autofill implementation, and then allows the system to pass that down to the keyboard. So there were also changes outside of the platform. All the rest of that stuff was Android 11. In Jetpack, I was told this is way out of date. There are way more than 80 libraries in Jetpack. This thing is huge, and there are releases every 2 weeks, everything from developer releases, especially for Jetpack Compose, alpha releases, beta releases, several of those going on, maybe one or more RCs, and then finally stable. So if you look on the release page, stuff going on in Android X all over the place all the time. Some of the exciting new stuff that we have out there includes HILT, which is the recommended approach for dependency injection in Android. It is built with and on top of Dagger, and basically a replacement for your use of Dagger if you choose to use it. It's a lot less complicated to use. It requires less code for one thing, especially for Android use cases, and it requires less sort of everybody understanding everything that's going on with Dagger. It's really targeted at exactly what Android developers needed for doing dependency injection. So worth checking out. Oh, also, I don't think I mentioned this elsewhere. We just posted a podcast with Danny Santiago and Eric Chang from the HILT team, from a couple of different sides of the HILT team, talking about how this stuff works. Paging 3, you just heard about that from Florina, so I don't think I need to talk about that one. Camrax beta. Camrax has been out for a while, since last year. It went into beta recently, so worth checking out that as that approaches stable, basically making it a lot easier to write camera applications, especially ones that behave appropriately across this massive ecosystem of different devices and releases that we have across the world. Jetpack Compose is the future UI toolkit for Android. I say future because it is not even alpha yet, but it is being developed in the open. So it's in open source. You can check out all the code. You can check out sample and tutorial, see what this involves as it swiftly approaches alpha. It's a reactive-based model. We believe this is a really powerful way to develop UIs. It's Kotlin-based, which is also really good for UI development, all the asynchronous stuff that we have to deal with all the time, for all the UI thread stuff that we love. And as I said, pre-alpha. Android Studio, 3 releases to know about right now. 4.0 went stable recently. Motion Editor just came out. So Motion Layout has been out for a while in various forms, but it was really always intended to be used with a visual editor. It's tricky to write animation code in XML. People were doing it, but you're sort of limited by how to actually do the stuff when you can't visualize it. Motion Editor allows you to visualize and use the visual tool and pop back and forth between code and the WYSIWYG designer. Also, Layout Inspector has been substantially rewritten with more capabilities for inspecting, where did that particular style attribute get set, or also visualizing your view hierarchy with a 3D viewer that allows you to understand how the containment hierarchy really works. 4.1 went into beta recently. Database Inspector is there, so you can make changes on the device or on the host and see those reflected live on both sides, as long as you're using SQLite or Room. There's a video and article, I think, that just got posted in the last couple of days from Murat that are worth checking out if you want to know more about how that works. And 4.2 went into Canary recently, the wireless debugging, so you can actually access this through the tool if you're using that Canary version. Or also, if you want to do Jetpack Compose developments, since it is not even alpha yet, we are only allowing that from the Canary releases. So if you want to play around with Compose, you're going to need the 4.2 Canary build. On the game sides, we have an Android game SDK that's worth checking out. Frame pacing and Android performance tuner, some of the new capabilities there. There's a video that Dan Galpin posted recently to show you how to use Android performance tuner. And this is about getting performance metrics from your app in the real world and having those auto uploaded into your dashboard, into the Android Vitals dashboard in your Play console. Play asset delivery, Dan also talked about that in a separate video in a new playlist that he has called The Game Show in the Android Developers channel on YouTube. New profilers in Android Studio, including one for GPU profiling, which is in beta that you can sign up for. So check out d.android.com/games. On Play, the big development there is there's a new Play console. It had been developed sort of piecemeal over the years, and it was getting a bit messy and hard to find stuff. So they basically rewrote the entire thing to be easier to use. That's the really big takeaway. Easier to use, but lots of capabilities in there. Reports on where user acquisition is coming from, how to manage your team of people that are accessing the console. It is in beta, so please check that out and see how it works for you. If you want more information on all of the changes in Android 11 and all the other stuff that I was talking about, first of all, go check out the launch video. So for instance, in the privacy area, there were 2 videos specifically devoted to much more of a deep dive into all of those privacy areas. There's also a video on Compose. There's a video on Android Studio, on and on and on. So check out the launch videos for the Android 11 launch. 11 weeks of Android is ongoing. This week, we're doing Android tools. I think next week is distribution and monetization. And then let's see. Oh, I can just read it on the screen here. Their form factors beyond phones, games, and media, and UI. We also have Reddit AMAs going on. One happened, I think, about 3 hours ago. But there's another one coming up in 4 weeks in the UI area as well. And Android 11 meetups, I don't have to say much about that because that is what this is. But if you enjoy this one, there are other meetups going on with other talks. So you can check out the site there and tune into other ones all across the world. And then finally, I want to put a plug in for a series that I've been doing recently. I think that it's complicated to figure out what's going on inside of Android. On the outside, it must be impossible. There's so much that the team is doing constantly, whether it's pushing a new release of Android 11, whether it's a new release of the tool, new Android X releases, other libraries that are coming out, other teams doing stuff, videos, articles, blogs, code labs, samples, all this stuff all the time. How do you follow it all? And so I wanted to try to collect that in one place and sort of look at the highlights, not everything, because then that's not reducing noise, it's just doubling it. But sort of look at the highlights of what happened every 2 to 3 weeks and just talk about it briefly so that you can get kind of a mental model of what happened, and then you can chase down the links for more information on the ones that you would like more information on. So check out Now on Android in that site on d.android.com, and that is it. Thank you. And now an awkward pause.
How much longer would you like to pause? Take. All right, sweet. Excellent. Perfecto. Get some other words in there. I guess we're going to give everybody a few minutes to type in questions in the Q&A and up questions that you think are interesting, and then Chet can pick what he wants to answer.
Sure, I'll start. There are some with multiple votes on them, so I'll start with those. Will the new window insets IME animation APIs have a compat version so it will work with older Android versions? I think I even asked about this when we talked about IME animations in a podcast episode some number of months ago. I believe they were looking at doing part of it in compat, but they can't do the entire thing. So, I mean, in an ideal world, we would release all pieces of software in a way that worked on all versions. Like, we know that this is difficult, but some of the raw capabilities of Android are offered at a system level, and that means you need to update the system in order to give that capability. And this is true for at least part of what IME animations do. You're really dealing with information that the window manager has, right? Well, we can't, go back a different version or two and ask the window manager for information that it didn't have at that point, right? So there is part of that equation, and I'm sorry, I can't remember the details of which part we could possibly port, but certainly not the ability. But like, I'm thinking of this as two sides. There's the one where you can listen to changes, and there's the one where you can drive changes for the keyboard. And I think one of those was just physically not possible on older versions with a compat approach, and the other one they were looking into. Is Wi-Fi debugging only available with Android 11? I believe. You know what? I'm gonna go. I think so, but I want to double check my logic there. Give me a second. I don't know. I think I'm conflating that in my mind with ADB incremental, which I think is locked toward Android 11 devices. But I don't see that constraint in the notes that I had made here. So I don't actually know. All right. Let's see. Will there be backwards compatibility for the bubbles? I don't believe so. I think that's another one that relies on some platform capabilities. There is a camera X. Believe me, especially the closer you get to UI, stuff like that, like the team, if they can do it first or even only in Android X Jetpack libraries, that's where it's going to appear. So you're not going to see it appear as only a platform library if there was a choice in general, because I know that's, especially for some of the teams, it's really been a priority for a while. Sorry, to be unbundled and be able to work cross releases. Does the IME animation work with other keyboards as well? Yes, it is an IME animation. It is not a Google keyboard animation. So I assume, I haven't done IME development, but I believe they have to plug into the whole IME framework in order to be shown at the right time when the users are clicking on things. So there's really a whole system designed, I mean, from almost 1.0, where you could write a keyboard and have it basically swap in without the system even knowing or caring whether it was a Google provided keyboard or not. So all of this stuff should work just fine. Now, if they're already doing some other workaround, if they have their own API for you to be able to query their keyboard for some of this, like, well, we're not taking that into account. But yeah, the capabilities that I mentioned are sort of overall system. Do users opt into bubbles on a per app basis or per person basis? I would assume it's on a per app, but I don't know offhand. That's a good question. I don't know if there's like a larger, because you are, I don't know if there's like a larger concept of a person that is, that's handled across the system. Huh. I would have to ask that team. And they are not in my house. Currently, there are limitations to the type of Android Auto you can build, messaging and media playing auto. Are there plans to expand on this in the near future? If there's expansion there, I would expect that to be quite slow. Like this is not just, hey, it's taken us a while to do that. That's, hey, this needs to be a safe driving experience, right? And there are, you know, national and international laws to behave within. And so we're really limited in what we can do in terms of, you know, an interactive experience in this thing. I don't know the specific plans, and this being Android, wouldn't talk about future plans anyway. But really the intention from the beginning was to be limited to the stuff that could be done in a very safe manner. Auto revoke permissions, what's the time or how is it handled? So wait, I'll finish reading. Thinking of vacation apps or other kinds of apps that are not so often used. There is no specific time used. So we had another podcast, sorry to keep plugging the podcast, but it's kind of nice when we talk to the engineering team. It's a way for you to get information directly from them instead of indirectly from me. And so there was a podcast that we did with a couple of people from the privacy team, Sarah and Philip, and I think we talked about that exact issue, and there are no specifics on that because it is a heuristic that we use that we may tune over time. So you shouldn't lock into any specifics there anyway, because that number may change. I don't know what it is set to now, but it doesn't really matter because that may change.
Chet,
yeah.
One person here named Anton, I have now consistently 2 events in a row deleted his top question, thinking that it was already answered. So I prematurely deleted it. He asked the question, Camera X makes working with cameras a lot easier. Is there a Bluetooth X for Jetpack in the works?
Again, this being Android, I wouldn't answer that if I could. I do not know. I would love to have a piece of paper sitting next to me where I can take back questions. Yeah, I don't know. I'd be afraid that there's too many dependencies on hardware stuff, but that is kind of the problem that Camera X solved, or is constantly working on, is, you know, sort of putting workarounds in the library. Yeah, I'd love to find out the answer to that question. I'll go ask it myself. What is the future of Android TV? You remember when I talked about not talking about futures? This would be one of those questions. How to revoke permissions? Like, it still exists. Let's be clear. I'm not saying scary stuff. I'm just saying I don't talk about future development stuff for the platform. Auto revoke permission. Oh, wait, I already did that one. Can we run local component tests using Wi-Fi debugging? I mean, Wi-Fi debugging should be the equivalent of directly plugging it in. So I'm not quite sure. I'm not sure what's being asked here, because at a trivial level, you should be able to do anything that you could do on a local device that's plugged into a USB port. It's just that we don't use USB. What's new for platform developers? Any new tools like? Well, if you want to wait for 50 minutes, I could go do the presentation again. New tools like debugging tools or ID integration. I don't know exactly what you're asking about here, but I didn't go into detail in a lot of the new Android Studio. You know, this says platform, but you're really talking about Android Studio stuff. So I would suggest that you watch 2 things. So there was a launch video called What's New in Android Studio, or What's New in Android Development Tools or something. So go watch that. That's sort of a high level view of what the state of tools was at in sort of late May, early June. But also this week, we're posting tons and tons of content specifically about tools. So I think, you know, that one got a rerun this week, but there's all kinds of other things that are deep dives into all of the stuff that's been going on, from the database inspector, layout inspector, the build analyzer, like all the new tools that have come online recently. Maybe there were even new ones that came out this week, I don't know. So go check out the 11 Weeks in Android site. And in particular, there will be a wrap-up blog. So there's 2 ways to follow the content in 11 Weeks in Android. At the end of each week, we have a wrap-up blog that has links to most of the stuff that was posted. So if you're not getting to it until after the week is done, just go click on the link to that week and it'll take you to the blog that has an overview sort of description of everything going on in that area, and then links to all of the stuff. And, you know, there's pathways in there that are, you know, links of links of links. The other way to tune in on a more live basis is if you follow the Android Dev Twitter handle. There's a hashtag that they use, hashtag 11 weeks of Android. So if you follow those two things together, then you will see all the tweets as they come out through the week. And most of the ones coming out for this 11 weeks are really focused on 11 weeks content. So this week, for example, almost everything they're posting is directly related to tools information. Then you can go access the article and the video that's coming up. And then the other way is just, you know, watch the Medium site and the Android blog and the YouTube channel for all that content. Can we expect particle system sprite in the future? Again, future, but I have not heard of this as being a priority, so I'll talk about past and just say I'm not aware of anything that we're talking about here. Is Google Wear platform dead? As far as I remember, there were no updates in years since introduction of complications. No, it is not. And anything else would be talk about future, so I won't do that. Is there any improvement for autofill keyboard integration? Again, if you give me 50 minutes, I can go back and give that presentation again. Yeah, so please go check out the information I posted. And there's more information in the documentation. And the beta documentation for the release about all the autofill stuff that we did. What is the Jetpack in Android 11? I don't understand that question. Where is all the sensitive information saved? Cards, passwords? Is it necessary for the user to opt in to save it, or will the keyboard? I actually don't know. That gets way into security about where stuff disappears in the platform, and I do not know. Yep, mystery to me. I'm not sure that anyone knows. Will bubbles be specific? Oh, this is a repeat of an earlier question. As far as I know, that is not back portable. That depends on platform capabilities in Android 11 or later. When can we expect Jetpack Compose to be stable? I thought there was, so if you go watch Clement's talk from the launch event, he gave more details about Jetpack Compose. I thought he was talking about coming up to the team trying to come up to alpha in the next few weeks. The details are sketchy to me. But yeah, we're trying real hard to get there. In the meantime, it is getting more solid. I talked to one of the people on the team earlier today, and they said like a lot of the core fundamentals are really solidifying right now, which does not mean that the API is not changing, but at least they're sort of, you know, zeroing in on exactly what they want the API to offer. But then there's, you know, nuances about how it can be offered. Any updates for TV leanback? Similar to other question, I don't have any updates right now. Where's all the info bubbles piece? I'm seeing a lot of questions already answered. In Android 11, a permission is permanently denied if the user denies it twice. Why is it? Why it should show rationale triggered after the first deny if it's going to change? I mean, the intention of that behavior is to not annoy the user, right? We're trying to involve the user, tell them exactly what's going on. So if they denied it, we give you a chance to explain, no, I really need this information, here is why. If they deny it again, why should we ask them again? Like, they told us twice. So it's unfortunate that the application didn't get to do what it needed to do or wanted to do, but we're making a choice on behalf of the user to make a better user experience so that they're not constantly needing to tell the system again and again what their intentions were with that permission. I'm trying to see if anything got popped up in the votes. So when can we expect a stable permission? What about some requests? Can we present these to you? I mean, if you write a request in here, I will try to send it to the right team. Sorry for the silly question. Could be other applications of this. Also, would you be able to pull the keyboard from other places of the UI? No. I mean, I guess you could quickly move that keyboard off to the top of the screen and pull it down. I suppose you could play around with the translation parameters to really draw it in a different location. You're not going to be able to like physically move the keyboard to be located elsewhere. The IME, I don't think was written to be sort of generally flexible on geometry, but just the ability to, if you're able to frame by frame animate it in from the bottom, then in my pretend world anyway, there's no reason why you couldn't also just animate it in frame by frame from the top. But to be clear, I think that's a horrible user experience, right? Like one of the things that's nice in a device for users is predictability. This is why in general, we don't really recommend using custom window animations, because the user's already used to a particular way that the device works. And if you're basically moving things out from under them, probably a bad idea. Maybe you had something else in mind here, but I think this is one of those like, yeah, you could, but you probably shouldn't. Is there a way to check if the permission is permanently denied? I do not know that, sorry. We need to debug our apps over Wi-Fi. Great. Oh, good question. Okay, awesome. I think that was all. Did I miss anything?
I think that is all. Yep.
All right. Cool.
Perfect.
Sweet.
All right. Well, thanks to the 111 eyeballs that I still see listed on the channel.
Yeah. Thanks for the questions, everyone, and thank you.
Yeah. Thanks. That was great. Sorry for the ones that I can't answer. There are always a bunch of those. Oh, well.
Sure.
Yeah, I think we should fight harder though. Chet, I mean, what? It's only like you're 3 hours behind. It's probably like 4 p.m. for you. You should just stay online and answer those 40-minute questions that you talked about.
Sure. Yeah. You know what? I'll tell you what. I'll turn my camera and mic off. But I'll totally be here the whole time. Yeah, look for me. It might take a while. Yeah.
I swear. Yeah. I was there the whole time. Yeah.
Yeah.
That's good.
Oh, there's another one. What would you tell other device users to switch and try Android basing on the device structure? I mean, one of the attractions to the Android ecosystem has always been the choice. Right? You have so many different devices, so many different form factors that you can opt into, so many different capabilities it appeals to people that want that degree of choice, you know, whether it's a price point choice or a form factor choice or whatever. For the specific capabilities, like, you know, things are converging. Like I'm sure, you know, every platform has the things that they specialize in, but a lot of the interesting thing to me is there used to be a lot more delineation between the platforms, and it was more important what the platforms did. But I think more and more people's lives are driven on these devices by the applications that they're using. So it's really more important, well, what are the apps and how do they work? And if it's a big app, chances are it's on both. So then they're making choices based on other things like, you know, how they like the screen and how the camera works. As you know, the raw capabilities, the 90% of what they do on the device might be the same. They're going to, you know, run that messaging app on both devices or whatever.
So I think well, first and foremost, Lucas, I'll let you give the thank you.
Yeah. Thank you so much, Chet, for your time.
Sure.
For being such an awesome speaker and telling us all the good new stuff in Android 11.
My pleasure.
We are a big fan of your podcast as well. So keep it up.
I will pass it along to Tora and Roma. All right.
And I will send you this awesome shirt about GDG location as well.
Excellent.
Okay. Thank you. Thank you so much for being here.